Supportability, adaptability, maintainability, internationalization, configurability. A lot of times when you build a system, you're not customizing it for one person. You might be building a product that you hope to sell in different countries. You got to be able to use different types of currencies, right? Configurability, we'll see more about this later in the course, but your system might be interacting with different types of hardware that use different drivers. So how do you build a system to do that, right? You don't want to hard code all the drivers in there, and before you deploy it, okay, we gotta change the code every time you deploy it, because it's going to be a different compile, a different build based upon which hardware driver you're going to be interacting with. What would be better would be if you could have somehow the system be smart enough to read a configurability file and configure itself. That way, when you deploy the system, all you do is you just deploy a little file and says, okay, these are the drivers you're going to be using, and the system reads that file, and boom, it knows which drivers to interface with. And we're going to see how to do that later on in the course, too. There are certain development patterns that allow you to do things like that. Plus is the plus part out here. This is pretty much anything else. Okay, this would be implementation, interfaces. Are there certain systems you're going to have to interact with? Operations. What are you deploying this thing on? Who's handling it? Who's maintaining the servers? How do you package this? Any legal implications? Okay. Usually you got people in your company handling this for you, but this is a big thing for you guys, and you'll probably see some courses in this. Of course, you're developing software. Software gets used by people. Something goes wrong. They lose money. Here comes the lawsuit, right? Yeah, your system went down and we lost this much sales, or we ended up not charging people. This happened, what was it, with JetBlue or somebody just a few weeks ago, right? They accidentally posted like $9 fares or something. Right? People were flying, well, they got to honor them, right? I guarantee you, whoever developed that system is probably going to be hearing from some lawyers, right? And if you're doing something that's really important, really serious, like a medical application or something, for assigning drugs or something to a patient, something screws up, then you could really find yourself in trouble. So, there's legal aspects here too. We're not going to cover any of that in this course. That's, you guys got other courses to deal with than that. That's the plus. That's what the plus is. Everything else. The main ones that are really important for us, functional, which is anything behavioral versus non-functional. This is everything else. The functional ones are the ones we're really going to concentrate on mostly here. Those are the things that come out of the use cases. It's how the system is behaving. What is the system doing? And then you got some quality requirements like usability, reliability, performance, and supportability. These guys are usually thought of as sort of quality requirements. Okay? They're really non-functional. They're important, but we're not going to spend too much time worrying about those. We're going to really concentrate a lot on the functional requirements.
A lot of people these days aim for scalable applications or scalable systems.
So where would that fall in here? Where would scalability fall in? I would think probably supportability. That might be one place. Yeah, it's probably how I would put it under supportability. Scalable is actually very important. It could be considered part of your performance too, but I would think probably more supportability. Okay, how would you expand the system if you had to? Okay, requirements organization. This is the unified process artifacts. There is something called the use case model. The use cases will primarily capture the functional requirements, how the system behaves. So, how do we start capturing these requirements? One of the key things that we develop in the UP is called the use case model. Okay, now, there's also something called a supplementary specification. That's another one of these artifacts. This is where a lot of the non-functional requirements are captured, for example, performance. And any functional features that are not captured by the use case model. There may be some functional aspects of the system that are not actually captured in the use cases. Okay? There may be some things that come up there, they would be captured in something under specification. These would come about if you're doing the investigation, you're going through the investigation of the system and the customer. We'll see more about that later on. There's also something called a glossary. The glossary, you'll capture some noteworthy terms, but it can include a data dictionary, which may include any requirements on data rules. Sometimes if you've got objects that are passing data back and forth and you want to make sure everybody's everybody knows what this data format is, you can capture it in the glossary. Glossary is actually really important, and when I was writing standards, it was probably one of the first things that we would start in the very beginning before we wrote the standard. Let's start with the glossary section. Why? Because it gets everybody on the same page. Everybody's using the same terminology. If you're working with different teams, different people, and you may not even be co-located, right? And you're not talking to the customer, you are talking to them regularly, but not every single day. You want everybody to be on the same page. Okay, if I tell you what a particular component is, and if I talk about a border gateway router or something like that, I want everybody to understand what that is, right? We all have to be on the same page. Glossary document does that. And the vision document, which essentially comes out of the inception phase, this will capture the high-level requirements. As I mentioned, during inception, you kind of do a feasibility study, but you will look at some requirements, some high-level requirements in your early going. You will look at some critical use cases and develop them, and they can be captured in the vision document and also in the use case model. And then you'll have something that's called the business rules or domain rules. These are usually transcend any one project, and so they be captured in one place for use by several projects. So these are like regulatory requirements, okay, tax requirements and stuff like that. You may have certain regulatory requirements depending upon where you're deploying your system. These will be captured in what's called the business rules artifact. Artifact here, you can think document, but it doesn't have to be a paper document. It could be a website, it could be a, like I said, an Excel spreadsheet, or a Wikipedia page, something like that. So an artifact is just something physical that captures this information. And that's how you would do it in UP. These are particular artifacts that come up in UP, and we'll see these guys more throughout the course. Okay. This diagram, which is probably a little hard for you to read, comes out of the book, but this kind of gives you a pretty good idea of what's sort of happening here and how these things interact. It shows the relationship between the various artifacts and the main disciplines. Now remember, we said that UP has various disciplines. There's sort of like processes that people go through that are grouped together. And you have various artifacts that get created in these disciplines. The main disciplines we're going to consider business modeling, requirements, and design. There's a few other ones in there as well. There are other disciplines in the UP. But the three main ones that we're going to be concerned with are business modeling, requirements, and design. And as you go through the various phases and iterations in UP, each of these disciplines create various artifacts. The business modeling discipline will create something called a domain model. And we're going to explore that in a couple of weeks. Basically what that is a model of the physical system that you're attempting to build your software to. You have to have an understanding for what it is that you're trying to build, that you're trying to model. And you start off with what's called a domain model. That sort of defines the domain you're going to be working on. We're going to spend some time learning how to develop domain models. This is where the UML, Universal Modeling Language, is going to come in. The requirements discipline is usually responsible for the use case model. This is kind of a busy little picture here, but you have like a use case diagram, and you have some use case documents here. And then down over here, you've got some system sequence diagrams and operations contracts. Those are all part of what's called the use case model, and we're going to actually explore that a little bit more. We'll explore each of these in detail throughout the course. Okay, these things impact the vision document, the glossary, and the supplementary specifications. We're not going to spend a lot of time on these artifacts. These are things that actually get created in a unified process. We're going to spend a lot of time here. We're going to spend a lot of time studying the domain model. We're going to spend a lot of time studying the use case model. And then down here in the design discipline, the artifact you create is called the design model. And there's actually two parts to it that we're going to study. The interaction diagram, which basically show you how the objects interact with each other. And then the class definition diagram, which essentially shows you what the classes are, okay, and how they relate. Those are both UML diagrams. We're going to spend a lot of time on this toward the end of the course, okay? This is the use case model. It's made up of use case diagrams. I'll talk a little bit more about those this morning. We'll talk about the use case document itself, the use case text, and we're going to spend a lot of time on that. And then I'll talk about these guys later on, system sequence diagrams and operation contracts. All you need to know right now is that these things all sort of influence each other, right? The use cases are usually the things that get developed first. Use cases will impact the domain model. They will also impact the vision document, the glossary, and the supplementary specification, because sometimes you pull requirements out of here, and they end up in here. And they also impact the design model, of course, because when you go to design the system, you're going to really have to know what the use cases are. What's not shown here is that the domain model also impacts the design model. Okay, the domain model is going to give you your clues as to what your objects are. But that's all coming in the months ahead. Okay? All right, we're going to spend a little bit more time studying use cases today, because that's usually the first step. And what you see is that this guy impacts a lot of other guys. He's really important. This is how the system works. So let's take a closer look at the use case model artifact. Part of the requirements discipline in UP, right? It's done by the requirements discipline. What is the discipline? The discipline you can think of as sort of a grouping of talents, a grouping of similar workings, okay? It doesn't necessarily have to be a particular physical group of people, but it's just sort of the discipline that you're going to follow. The requirements is going to be one of them. Composed of use case text documents. Text documents. Okay, this is one of the things I'm going to really stress here. Use cases are text. They're not pictures, they're text. They're stories. May include some UML diagrams of the use cases which provide context diagrams of the system, but they are not diagrams, they're text. Essential to OAD. Although OAD is not used to develop the use case model, we're not actually going to be using object-oriented analysis and design yet. The use case model, you really don't need that because there's no objects yet. We haven't identified any objects. That comes later. First thing we're going to do in this use case model development, we're going to figure out what the system is doing. That's what the use case model is, okay? You tell the story of how the users use the system. That's what the use case model is. Use cases are requirements, primarily functional. They tell you how the system behaves, what functions it does. Use cases provide an essential understanding of how the end user will use the system and are critical to the proper requirements definition. Okay? Usually the first and most important step, right off the bat, get the use cases nailed down. When we were doing the standards for wireless technology back in the late 90s and early 2000s, I think I told you this, people were trying to figure out how people were going to access the internet on their phone. Well, the internet, there was no app store, there were no iPhones, there was no such thing. Very well, people surf web pages. And I remember sitting in meetings and laughing, going, who's going to look at a web page on a screen that big? You know, we had no idea. We figured people would look at emails. Those were the use cases we had, okay? This is tough because this assumes that the customer knows what they want and how the system is going to be used. Now, in the standards case, it was difficult because we were designing a system where the requirements and the use cases were very vague, okay? We didn't know how the system was going to be used. Usually, if someone's going to buy a system, a software system from you, they've got a need, they know what they need. They're going to be able to tell you, we need a system that's going to do this. The do this part is the use case model. This is exactly what the system's going to be doing. Key features. Use cases are text, not diagram. We may construct diagrams from the text later, and we'll talk a little bit about how to do that, but the key part here is that these are stories, and as part of the stories, the functional requirements are revealed. When you write the stories of how the system gets used, that's where the functional requirements come from. You start seeing how the system's going to function, how it's going to behave. You've got to identify the actors. Actors in a use case is something that exhibits behavior in the system. It's not just a person. It can be another system, okay? So one of the key things you do right up front is you identify the main actors. Who are the people that are doing things? Who are the people that are exhibiting behavior, okay? You identify the scenario. You have got a specific sequence of actions and interactions between actors and the system. That's a particular use case instance. You don't want your use case to include everything. Usually, one use case identifies a particular scenario, okay? So think ATM, logging into the ATM. That's a use case, right? Withdrawing money or accessing your account, that's a use case. Logging out, that's a use case. Putting in the wrong PIN number, we'll see how to handle stuff like that later on this morning. But what you do is you break these down to a single scenario, and this is a bit of an art form too. You don't want your use case to be too complicated, but you want it to be substantial, okay? So you don't want a use case for the ATM example of for putting in every single digit of the PIN. Okay, that's too detailed. You'll have too many use cases. It's kind of an art form trying to figure out what's a good scenario, what's too complicated, and what's not complicated enough. This is something you'll pick up over time as you get more experience doing this. Here's an informal definition of use case: collection of related success and failure scenarios that describe an actor using the system to achieve a goal. And one of the key things that we're going to discover when we look at these use cases: identify the actor and identify their goal. What is it that they're trying to do? In the case of the ATM machine, one actor would be the guy who's using the ATM machine. What's his goal? He wants to get money out of his account. Another actor would be the bank. What's their goal? They want to make sure that this is secure and they're only giving money to people who have accounts and have enough money to take money out of the ATM. That's their goal. Identify the actors, identify the goals, identify the behavior and the action, and you'll get your use case. This is a more formal definition. This comes from RUP, the Rational Unified Process. They wrote this out in detail. A set of use case instances, scenarios, where each instance is a sequence of actions a system performs that yields an observable result of value to a particular actor. Okay? That's a use case. Okay. One of the skills you're going to need in use case development and analysis: identify the nouns, things, objects in the use case, and the verbs. Real critical. Okay? The nouns usually tell you the things that are happening in the system. That's where your objects are going to come from. The verbs are basically the actions. They're the things that are happening. That's where your behaviors are going to come from. Nouns will eventually give you clues about the objects in the system. The verbs will give you clues about their behavior, their responsibilities. And remember, I kind of mentioned this last time. I said when we start getting into this object-oriented design, when we get to the design phase, the key part is going to be identifying the objects, which are going to give you your object, your classes, and your code, and then assigning the responsibilities to those objects. What do they do? How do you define the methods? In order to do that, you're going to go back to the verbs and the use cases and say, this does that. That will help you understand how these objects are going to behave. For example, suppose we have a use case with the sentence, the line item is added to the sale. Okay? Look at that. The line item is added to the sale. In this particular case, sale is a noun, it's something. Line item is something. You'll know what a line item is? This is a line item. So this would be a sale, and a line item right here is 1 Bud Light, 1 Bud, 2 beef burgers, 20 bucks for 2 burgers. Wow. Not McDonald's. Okay? That's a line item. Right? So if you were doing some kind of a system to handle this, to process this sale, you might have this sentence, right? The line item is added to the sale. The sale is the overall sale. The line item is each one of these things, right? So you've got nouns, line item, is sale. These are going to be likely objects in the system. When we create the system, we're probably going to have a sale object. We're probably going to have an object that describes line items. Now, you're not going to have when you design this, you're going to have a general line item object, and these would be specific instances of that object, right? And we know something. We know that something must have responsibility for adding the line item to the sale, because there's an action here, right? The line item gets added to the sale. That's a responsibility. When we design the system, something is going to have to handle that responsibility. Who's going to have the responsibility of adding the line item to the sale? Something in our system must do this. That's a functional requirement. Now, for where we are this morning, all we're going to do is figure out how to write this sentence. The action of going through here and picking out these nouns and identifying the objects and figuring out the responsibilities and then figuring out who's going to handle that responsibility, that's the rest of the course. It's going to take us weeks, if not months, to develop that. There's a whole methodology for how you do that. What I'm pointing out here is where we're going with this and why use cases are so important. The use cases, which are text, carry all this information. They're going to identify the objects that are going to make up your system, and they're going to identify the responsibilities that they have to do. We'll later see that it's probably a good idea to have the sale be the one that handles that responsibility. And when you do your design, that's basically what it comes down to. You're going to have all these responsibilities that you've got from your use cases, and you're going to figure out which object is going to be responsible for doing that, and then that's how you define your methods for your objects. Okay? All right. How we doing? 11 o'clock. I've been babbling for an hour, and we're only like halfway through this slide deck, so I got to talk faster. Does anybody have any questions? I promised you guys I would take a break after an hour, but we gotta go a little bit longer, okay? Here's a quick example, ATM use case session. This is actually kind of a long statement here, but this is one I kind of probably copied this off the web. Just did a Google search for use case. So this would be an example use case. A session is started when a customer inserts an ATM card into a card reader slot of the machine. The ATM pulls the card in the machine and reads it. If the reader cannot read the card due to improper insertion of damaged strike, the card is ejected, an error screen is displayed, the session is aborted. The customer is asked to enter his or her PIN and is then allowed to perform one or more transactions, choosing from a menu of possible types of transaction. After each transaction, the customer is asked whether he or she would like to perform another. When the customer is through performing the transactions, the card is ejected from the machine, the session ends. If a transaction is aborted due to too many invalid PIN entries, the session is also aborted, the card being retained in the machine. The customer may abort the session by pressing cancel key. Okay, that's a fairly detailed, kind of a long-winded use case, but this sort of describes the overall process of logging into an ATM machine. Now notice, the guy doesn't actually do anything in here. He doesn't take out money, he doesn't check his account or anything like that. This is just one scenario of how to successfully get into an ATM machine to start the session. Now, if something goes wrong, they say, okay, when you're done, this is how you end it, and if the transaction is aborted due to too many invalid PIN entries, the card gets retained. This is the type of use case you might get from a customer. They would sit down, they would decide how they want their machine to work, and they would write this out and give it to you. And your job would be to go through this thing, pull out the nouns and the verbs to start doing the analysis. Okay? So take a look at this. This is essentially what I've highlighted here are the main nouns. We've got a session, we've got a customer, ATM card, card reader slot, machine, ATM, stripe, error screen, PIN. What you would do with this, first off, you probably go through and identify all these key items, because they're going to probably tell you, give you some clue as to what the objects will be. Okay? That's usually the first step. Go through and identify the key nouns. And these are sort of the main things. You got a menu here, you got the PIN, things like that. The next thing you would do is you'd go through and you'd sort of identify the verbs, the action. Started, inserts, pulls, reads, ejected, displayed. Customer is asked to enter his or her PIN. Okay, that's going to translate to something in the system, or display some type of a screen. Allowed to perform, okay? Choosing from a menu, asked, ends. When you do this type of analysis, you'll pick out the responsibilities for what the objects are supposed to do, okay? Okay. I just wanted to highlight that and sort of show you how that basically works, how you would read through a use case and identify things like this. That's going to be a critical task. Actors and use case formats. Actors, anything with behavior, including the system itself. This is somebody that has some type of behavior in the system. Primary actor is the person or the object or whatever it is. Primary actor is the thing that has goals fulfilled by the system. This is the main user, the main actor that is going to have his, her, or its goals fulfilled by the system. You can also have supporting actors, something that's providing a service, and offstage actors. They carry the cliche a little far here, but offstage actors, which have some interest in the behavior of the system, but they're not primary supporting, like a government agency or a monitoring system. What's a supporting actor? This would be something like a tax calculation system or an inventory system that you're going to interface to. Okay? So your main primary actor would be like maybe the user that's actually using the thing. If we go back to that point of sale application, you may have an inventory system that automatically gets updated each time a sale is concluded. That would be a supporting actor. Okay? These do not define objects necessarily. These are the main actors that are going to interplay, interwork with your system. Use case types. You can have brief or casual. Short text descriptions, either one or a few paragraphs. Or you can have what's called fully dressed. These are detailed and they usually follow a template. Okay? We'll take a look at the template. The book has a pretty good template. We'll look at that in a minute. Okay. You guys want to take a quick break now, or do you want to go for a few more minutes? It doesn't matter. Let's just try to get through these. Wow, man, I'm going really slow here. Okay, give me about another 10 minutes, then we'll take a quick break, then we'll come back. Okay, I gotta step it up. Okay. Here's a look at the use case template. This is in the book. Okay. And I'm not going to go through this in gory detail, but this would be an example. Now, sometimes if you go to work for a company or sometimes a customer, they'll have the template themselves. They'll give you the template. The template in the book is a good example of a template to use. No, don't memorize it. I'm not going to ask you to, remember all this on a test or something. It's not worth memorizing a use case template. But you see what they've got here. They got a name. You always want to start with a name. Usually you've got some kind of a verb, which is because use cases are action. It gives you basic scope, which is the system under design, the level, user level, or maybe some function or something lower level than that. You always identify the primary actor, the actor that's going to call upon the system to do the goal. Stakeholders and interests, very important. List all the stakeholders in the scenario, what they expect the system to do. This identifies the behaviors. The primary actor expects, for the ATM example, the customer expects to get the money out. For the bank, they expect this to be a secure transaction. Any precondition and success guarantees, conditions that are relevant and considered true at the start of the use case. What must be true upon completion of the scenario? This is the result. This is what you want to have happen. Okay? The main success scenario. You then record the steps of the success scenario, including interaction between actors, and you usually do this in a numbered series of steps. We'll see an example of this in a minute. You go through one by one, you describe every step, every action. Then there's an extension section, and we'll take a look at this probably a little bit more next week. But if you've got a kind of a complicated scenario and something could go wrong and you could branch out, like in the ATM example, if for some reason there's not enough money in the account, the guy tries to overdraw something, you can branch out to another use case. And you can put those extensions in here, and we'll see how to do that a little bit more next week. Any special requirements, non-functional requirements, any constraints, any technology or data variations list, any obvious technology or constraints that you may have to have on there, and then you have miscellaneous. That's a pretty good template for a detailed use case, okay? You don't always have to go to this level of detail, but sometimes people want this, they want it formalized, so that's a decent template right there. Here's some guidelines. Defer all the conditional branches to the extension section. Concentrate on your main scenario. If you've got branch offs, okay, what happens if halfway through the sale, right up, the customer decides to cancel the sale? That's a branch off. You put that in the extension section. Write an essential style. Leave out user interface specifics. Focus on the actor intent. Okay, keep it very, very basic. The user does this. The user does that. The system does this. The system does that. Write terse statements. You don't want a lot of terminology here. It's a table. It's a template. It's a format. Keep it short. Okay. Keep it short. Use black box thinking. The system records its sale. You don't want to design here. You don't want to say the system accesses a database and generates a SQL insert. Way too low level. Okay, this is the key thing that you have to do if you're developing use cases. Do not design. Do not say this is how we're going to. This is not a how part. This is a what. You're explaining what the system does, and you'll say something like, "This is a what. The system records the sale. Is what it does. This is how." You don't put in how things into a use case, you put in what things, okay? Role play, become the actor, take the actor perspective, pretend you're using the system. Okay, this is where the customer can help you. A lot of times during these requirements workshops, they'll bring in the people, like if you're designing a point of sale application, they'll bring in an actual cashier and interview them. How do you do this? Go through the steps, show me exactly, maybe you'll go on site and watch them. Show me exactly how you do it. You scan this, you do that. Which keys do you punch? How do you handle that? That's role playing. You've got to see it from the actor's perspective to write accurate use cases. Here's a fully dressed example of the ATM withdrawal. Use case, withdraw the money from the ATM. That's the use case name. Notice starts with a verb, okay? Scope, this is the ATM system, this is the system we're developing. It's user goal, we're gonna identify our user goal. The actor, primary, the customer, the bank is supporting, the ATM is supporting, the ATM machine itself is a supporting actor here. Stakeholders, the customer wants to get his cash, that's his goal. Bank, provide the cash, properly record the transaction. Preconditions, there's an active network condition to the bank, connection to the bank, the ATM has the cash it needs. Okay, here's the main success flow. This is how you would write out the steps of the use case. Step 1, the use case begins when the bank customer inserts their bank card. And you'll notice I'm capitalizing sort of the nouns here, the things that are actually being done. Okay, you could also do things like underline the verbs if you want to identify the actions, but you don't have to do that. Use case, validate users perform. Now what that's telling you is that there's another use case here that does this. There's more steps in here, okay? So there's another use case called validate user here that you would do with this step, okay? The ATM displays the different alternatives that are available on this unit. See supporting requirements document with a list of alternatives. You can reference a supporting document here. In this case, the bank customer always selects to withdraw cash. Okay, for this particular use case, he's going to withdraw cash. ATM prompts the account. See supporting requirements for account types that can be supported. Oftentimes, you'll reference another document or another artifact here to get other specifics. Step 5, the bank customer selects an account. Step 6, the ATM prompts for an amount. Step 7, the bank customer enters an amount, step by step. And you see how this is written, very terse. The ATM prompts the amount, the customer enters the amount. Boom, boom. All the action steps, very direct. Main success flow. Card, ID, PIN, amount, and account is sent to the bank as a transaction. The bank consortium replies with a go, no go reply. This is probably a little bit more detail, but you can or you can't put that in. This is sort of telling you the information that gets sent as part of the transaction, is defined in the transaction. That's okay. That's okay to put in a use case. You could have just said the bank consortium replies, or a request is sent to the bank consortium and fill the details in later. But it's okay if you have it at this time, put in that level of detail. The money is dispensed, the bank card is returned, the receipt is printed. Use case and successful. Okay? That's how you would do a detailed use case step by step. Alternative flows, we leave some details out. This is the extension section. Invalid user, wrong account, wrong amount exceeds withdrawal. These are all things that we identified in the requirements workshop. What's everything that can go wrong? Amount exceeds daily withdrawal limit, insufficient cash, no response from the bank, money not removed, etc., etc. These are all things that would be identified. Or just quit, you can quit a transaction at any time. You'd have to branch out use cases for all of those. Okay? Okay. Those conditions, success guarantee, successful completion, users receive their cash and the internal logs have been updated. Failure condition, the logs have been updated. Accordingly. That probably would be true that have not been updated accordingly. Special requirements, ATM shall display cash and all those $1 this is made with the bank wants. Maximum individual withdrawals $500. They would use these types of requirements. ATM shall keep a log, including date and time, of all completed transactions. Okay, let's take a break here before we do the dog grooming example. Let's just try and take 10 minutes and be back, and then we'll knock off a dog grooming example, and then we'll jump into the next section. There's more use cases.